The 10th question that we have is again an analytical problem. We've been given that A1, A2, A3, A4 are the areas of the four faces of a tetrahedron, and N1, N2, N3, N4 are the outward normals for all these faces. Now the magnitude of N1 is A1, N2 is A2 and so on. We need to find out the value of N1 vector plus N2 vector plus N3 vector plus N4 vector. So for finding out this, let us first draw the tetrahedron that we have. Let this be the tetrahedron that we have. We can assume origin at any point as per our convenience. So let the origin be at point A. That is, the position vector of point A will be equal to 0 vector. This is point B, C and D. Therefore the position vector of point B, let it be B vector. For point C, let it be equal to C vector, and for point D, let it be equal to D vector. Now we know that since N1 has a magnitude of A1 and is perpendicular to the area, that is the surface area of the triangle, therefore this is nothing else but the area vector. N1 is the area vector of the first face, N2 is the area vector of the second face, and so on. Therefore let this face be the first face ABC. So for this face we can write AB vector is equal to B vector, that is position vector of B minus A. Similarly we have BC vector is equal to C vector minus B vector. Therefore the area vector can be written as half of BA vector cross BC vector, because we need to find out the outward normal. Therefore we have to do BC cross BA. Sorry, this will be BC vector cross BA vector, so that we get a outward normal. This is BC vector cross BA vector. Therefore we can write N1 vector is equal to BC vector is C vector minus B vector, half of C vector minus B vector cross BA vector. BA vector is minus of B vector. Now let us write the other vectors N2, N3, N4. Now N2 will be for this face. Now for this face we can write N2 vector is equal to half of CD vector cross CA vector. CD vector is D vector minus C vector, and the cross product of this we will take with, or rather what we could have done was that for N1 vector we could have directly written, we could have taken these two sides, that is AB and AC, and we could have written AB cross AC, that is half of B vector cross C vector directly also, because if we take these two edges, the area of this triangle will be half of AB vector cross AC vector, so that to get an outward normal. Similarly for N2 vector, this will be equal to, N2 is for this side, therefore for this side we can write C vector cross D vector, so as to get an outward normal, because AC vector is C vector and AD vector is D vector, therefore we get AC vector cross AD vector to get a unit outward normal, not a unit outward normal, to get a normal that is whose magnitude is equal to A2. Therefore we get N1 and N2. Similarly we can write N3 vector is equal to, N3 vector will be the face which is behind. For that we can write that to be equal to AD vector cross AB vector, so that we get it inside, that will be outward for the face which is behind. Therefore that will be equal to D vector cross B vector, half of D vector cross B vector will be N3 vector. Now for the face which is below, we can find out BD vector cross BC vector. This is because we need a outward normal which is coming downwards, therefore we will have to do BD vector cross BC vector to get it in the downward direction. Now BD vector can be written as, therefore N4 vector will be equal to half of BD vector is D vector minus B vector cross of BC vector, that is C vector minus B vector. Now we need to find out the summation of these four vectors. Let us add them all up. Therefore summation NR, R is equal to 1 to 4, will be equal to summation of these four vectors, which can be written as, let us take half common, This will be B cross C plus C cross D plus D cross B plus D cross C minus D cross B minus B cross C plus B cross B. This is equal to 0. D cross B minus D cross B again becomes 0. B cross C minus B cross C becomes 0. And C cross D plus D cross C is 0 because D cross C is minus of C cross D. Therefore, this whole term becomes equal to 0. Therefore, the value of n1 vector plus n2 vector plus n3 vector plus n4 vector comes out to be equal to 0. And this is our final answer.